Okay, I have a very, very surprising mathematical card effect that's actually based on some pretty high-level mathematics involving Markov chains. Now, this effect here is attributed to Martin Kruskal. In fact, it's called Kruskal's count. Okay, so he worked with Markov chains, and the best I know, he and maybe Martin Gardner came up with this way to frame a card effect based on some really powerful mathematics. Okay, so let me just explain to you kind of how this works. The spectator is free to randomly choose any card on the top row. And they secretly do it. They don't tell you. Now, once they've made a selection, they're going to use that card name and move a number of positions along these rows here, okay? And then they'll land on another card name, and that will tell them to do a certain counting with the next leg of the journey and so forth. And eventually they're going to land somewhere here in the bottom row. We won't know where. Now, the amazing thing that Martin Kruskal showed is that regardless of what the spectator chooses here for their starting place, if you randomly choose any one of these yourself, there is an extremely high probability that you and the spectator will end up at the same final card. It really is quite mind-blowing. And if you want to increase your chances as the performer in being successful in your prediction, it's recommended that you always choose the first card as your secret starting place, the 7. And so how the counting across the rows will go is we're focused on how many letters are in the card value name. So for example, Ace, 2, 6, and 10 have 3 letters in their name. Ace has ACE, 2 has TWO, 6 SIX, 10 TEN, okay? Whereas the card value names 4, 5, 9, Jack, and King have 4 letters in their card value name. And finally, the cards 3, 7, 8, and Queen have 5 letters in their card value names, okay? So the only numbers we need to worry about will be 3, 4, and 5. So why don't we, just for fun, let's say, since I recommended that you secretly, along with the spectator, you secretly choose this one, while they might choose that one, but likely one of the other ones. So let me just show you what you would be doing. You don't tell the spectator you're doing this. So what you would do is you'd look at that card. It's a 7. There's 5 letters in the name 7. Okay, so you'd start here and go 1, 2, 3, 4, 5. There's another 7, okay. 1, 2, 3, 4, 5. Now it's a queen. It has 5 letters in its name. 1, 2, 3, 4, 5. This is kind of boring. Sorry. I just randomly put these out here. The queen again. 1, 2, 3, 4, 5. This is amazing. 8. 1, 2, 3, 4, 5. Jack has 4 letters in its card value name. 1, 2, 3, 4. And then that's as far as we can go, right? Because we can't go 4 in that direction. So why don't I just go ahead and just jog out the 5 of... So starting here at the 7 of spades, this is where you would finish. Okay? Now the claim is the mathematics of all of this shows, in fact, if you focus on the second example here, that's what we're looking at. I have 4 rows of 10 cards. I have 40 cards. There is a 92% probability or chance that the performer and spectator will end up at the same final location here, regardless of what they choose. It absolutely is amazing. And here's a formula that gives you an approximation to the exact answer. Okay, so all I did was I plugged in 40 cards. X is the average card value. Well, the card values here are, as far as the numbers that we're counting, are 3 letters, 4 letters, 5 letters. Well, the average of all of those is 4 letters. Okay, so that's why X is 4 in all of these examples. And then I'm just changing the packet size. Now, when you get up to a full deck of 52 cards, there's a 97% chance of being successful. It's almost certain that this is going to work. Okay, but at 40, cards, we have a 92% chance. So quite likely. It's not guaranteed, but it's very likely. Okay, so starting here, which is where I kind of recommend that you start, why don't we just quickly go through and check these others. Now, you need to know that these were randomly put out, and that's the key too. From a shuffled deck of cards, you have the spectator just put out these rows, and I would recommend it 40 cards or more to make it quite likely that you'll succeed in your prediction. And so the order of these cards doesn't matter. That's the amazing thing. And the mathematics brings that out. It doesn't matter where these cards are or how they're arranged. There's a 92% chance that we're going to succeed. So let's say secretly the spectator chooses the ace as his or her starting place. Okay, so ace. So it has 3 letters. 1, 2, 3. So 4 has 4 letters. 1, 2, 3, 4. 3 has 5 letters. 1, 2, 3, 4, 5. 4 has 4 letters. 1, 2, 3, 4. Ace has 3. 1, 2, 3. 8 has 5. 1, 2, 3, 4, 5. Jack has 4. 1, 2, 3, 4. So starting at the ace of hearts, we also finish at the 5 of hearts. Let's check the 5 of clubs. 4 letters in that name. 1, 2, 3, 4, 5. 8 has 5. 1, 2, 3, 4, 5. Ace has 3. 1, 2, 3. Queen has 5. 1, 2, 3, 4, 5. 8 has 5. 1, 2, 3, 4, 5. Jack has 4. 1, 2, 3, 4. As we go through these, you'll realize at some point we're going to very likely get on the same path. So let me explain some of the theory of this very quickly, and then we'll check the other ones. Although the magician may not pick the same initial number between 1 and 10 for the starting place, there is a high probability the magician will still land on the same card as the spectator. Now, this is because even though the magician and the spectator begin on different paths, there will come a point simply by coincidence when the 2 players land on the same card. Like once we land on this 8 here, it's all done, right? Or, whatever card we were landing on that got us eventually to the 5 of hearts. Okay, and then once they land on the same card, their paths become synchronized for the rest of the journey, meaning you'll end up at the same final card. Okay, we checked the 5 of clubs. Let's do the king here. So king, 1, 2, 3, 4. 8's 5. 1, 2, 3, 4, 5. Ace is 3. 1, 2, 3. Queen's 5. 1, 2, 3, 4, 5. 8's 5. 1, 2, 3, 4, 5. There's the jack. 1, 2, 3, 4. Oh, same thing there. See, we've done the king. What about the 4? So 4 has 4. 1, 2, 3, 4. 3 has 5. 1, 2, 3, 4, 5. 4 has 4. 1, 2, 3, 4. Ace has 3 letters in its card value name. 1, 2, 3. 8 has 5. 1, 2, 3, 4, 5. Jack has 4. 1, 2, 3, 4. 7. So here, 5 letters in that card value name. 1, 2, 3, 4, 5. And then queen. 1, 2, 3, 4, 5. Queen again. 1, 2, 3, 4, 5. 8 is 5 again. 1, 2, 3, 4, 5. Jack has 4. 1, 2, 3, 4. And then 6. So right here, we count over 3 positions, right? 1, 2, 3. Oh, we hit a 9. I don't think we've hit this one yet. 9 has 4 letters in its card value name. 1, 2, 3, 4. 4 also has 4 letters in its name. 1, 2, 3, 4. Ace has 3. 1, 2, 3. 8 has 5. 1, 2, 3, 4, 5. Jack has 4. 1, 2, 3, 4. And then the final one. Theoretically speaking, on average, about 9 of these should take you to the same place, essentially. Okay, but it could be that they all do. That's the thing. So let's check. I haven't checked any of these before putting these out, so I honestly don't know what's going to happen here. Okay, so 8. There's 5 letters in that card value name. So 1, 2, 3, 4, 5. Ace has 3. 1, 2, 3. Queen has 5, 1, 2, 3, 4, 5. 8 has 5, 1, 2, 3, 4, 5. And it looks like Jack will take us 1, 2, 3, 4, same place. So it actually would not matter which of these 10 cards the spectator chooses, or for that matter, which one you choose. You're both going to land right here. And so while the spectator is kind of figuring out what their final landing place is, you can do the same thing for yourself if you want to start with the first card as a general rule or recommendation. And you'll discover that you land here. You just quietly note that. And then the spectator, when they're done doing their counting, will have a place down here where they've finished. And you can just look at them and say, I have no idea which of the 10 cards you decided to use as your starting position. But I just have a feeling that you landed on a heart. So I'm thinking it's one of these two right here. And in my mind's eye, I'm not seeing a small card value. I'm seeing kind of an average card value. So I think you landed on the 5 of hearts. Is that correct? And their eyes are going to go big and think, okay, you either are incredibly lucky that you guessed that, or let's do that again. And you can do this as many times as you like. And even with just 40 cards, you're almost certain to succeed. If you want to do the whole deck, it's all but guaranteed that you are going to be able to state where the spectator ends up on this final row. So anyway, thank you for watching. I think this is a very fun mathematical card effect. And those studying statistics and dynamical systems and stochastic processes, this is actually a hands-on model of what's going on with those theoretical models. You can really see what's going on here with just a packet of cards. It really is amazing and wonderful that we can kind of experience this deep mathematics using just ordinary playing cards. So thank you for watching, and take a look at other videos on the Absolute Math Magic channel.